As you get into the Amazon Web Service world, it won't take you long to come across this term, elastic computing. And then you'll see it again and again and again because it really defines the essence of what Amazon Web Services is providing. When I hear it, my mind immediately thinks about my pajamas. I don't have to wear a belt to bed because they stretch to accommodate me. And that's actually not too far from the truth. Well, I should say, in some aspects, it's very far. Other aspects, it's not too far from what Amazon Web Services is all about. And to drive that point home, I want to show you elastic computing placed in this case study. Let's say somebody came up to your organization and said, I want you within 2 days to scale to 5,000 servers. Most people would just look at them and go, you're crazy. You probably know where I'm going with this. With AWS and elastic computing, it is totally possible in a cost-effective way. Last thing that we're going to talk about in this nugget is the global infrastructure, as in if you're going to go Amazon Web Service, it'd be good for you to know exactly what you're getting into, like where in general is my stuff? How do I make sure that it's not all in one location? And if there's a bad hurricane at that location, that I lose all of my data until that data center comes back online. So we'll talk about this concept of regions and availability zones. I began getting into the concept of elastic computing in the last nugget on understanding the cloud and Amazon Web Services when I was comparing doing it yourself versus doing it with Amazon Web Services. So let me review where I left that off. I said, okay, doing it yourself. So here's our graph, right? We have capacity and time, and let's just say this is your data center. Let's give a scenario. You run a picture website where people can upload pictures to your website and share it with their friends and categorize and whatever else you want to do with pictures, right? So your website maybe starts with 100 subscribers, and so you buy, let's just say, 5 servers, a very small presence in a data center. So you buy 5 servers to handle that. Now with 100 user, maybe your actual load is somewhere around here. 100 users uploading web pictures. Here's at night and here's during the day. So you've got this kind of thing. But you've got these servers that are running that have no problem. They're not batting an eye with the capacity or the demand that's hit by the subscribers. Well, let's just say that you put a couple good Google ads out there, and the capacity begins to rise steadily to where it's consistent even at night, and maybe even exceeds what you have capacity for. Now, this is, we'll say, depending on your organization and how your financial position, you may address this before or after, but maybe it exceeds for a little bit. So what you have right here is a few customers that come in and they're like, hey, I tried to get to the website and it was either really slow or my friend couldn't see my pictures. I mean, that little colored in red blob right there is customer complaints, because now you've exceeded what the capacity is. So it goes down, nobody notices and all that kind of stuff. So you go, oh man, quick, meeting, we've got to buy more servers. So you order more servers. Let's say you double, you move to 10 servers, right? Boom, your capacity is right there, and now you move forward over time with that. And you can see that, people are surfing the website. Maybe you got those bubbles again that you're now addressing, no customer dissatisfaction. But all along, you have all of this stuff right here. All of this, kind of trying to color like all in the last nugget where I defined the concepts of doing it yourself. I asked, what is that? Well, that stuff is all wasted capacity. Right? It's stuff that you're paying for, servers that you've bought, power that you're consuming, hard drives that you had to initialize and you're running on, you got to replace your hard drives on your servers every such and such amount of time to make sure that they keep their data, and more backups. I mean, blah, blah, blah. It's all waste because your customers haven't exceeded that point. And then you have to wait until you grow, your customer base grows to that cap again, thus risking customer dissatisfaction because you're now hitting your peak again. Right here, and you have that little moment where people are like, oh, Jeremy's picture site is really lame. I tried to log in at noon. It was terrible performance. So you start getting complaints, and so you have to do that big step up again. Oh, let's add 5 more servers or 10 more servers or whatever. Now, here's the big issue. With the world on the internet, with the world being connected the way it is, a lot of times we don't move in steps of 5 or 10 or 15 servers. We move in massive steps. Like, for instance, you put a Facebook posting that goes viral. Right? Right here, you post on Facebook, hey, free you want to try and gain the masses. So you say free picture sharing services up to 2 gigabytes of pictures, and bam! Well, actually, sorry, it's not purple. Hopefully purple comes along with it. But bam! One day, you're because of that posting that did happen to go viral on Facebook or on whatever social media site that you have it posted on, you get 15,000 new subscribers in one day. If you haven't, first off, made a massive investment, let's say you've got 1,000 servers up here, a massive investment in servers to handle this gigantic load, your marketing efforts just gave you a black eye because 15,000 people came to your site, wasn't prepared for it. The site wouldn't even load, much less get somebody signed up to submit picture. And now you've got people posting to your social media posts being like, yeah, lame, I couldn't even get to your site. Hello, it's okay, you get where I'm going, right? So how is Amazon Web Services different? What is elastic computing? Let me define that. So elastic computing gives you the ability to scale your infrastructure as the demand is asking for it, and to, can I make up a word, descale, like shrink your infrastructure as the demand goes down. Here's what I mean. Let's say we've got that same picture website, right? We run it on 5 servers that are running all the time in Amazon Web Services, if we decide to go that way, because that supports the base. I mean, you've got to see a web page and all that kind of stuff. And we monitor the actual utilization of our servers. Now, we can monitor, you might say, well, what do you mean monitor? We can monitor based on anything: processor utilization, number of active users on the site at a time. We can monitor based on the memory utilization, based on the actual bandwidth that's being used. I mean, we'll get into this service of Amazon called CloudWatch, where you can watch just about anything. As a matter of fact, you can even create your own little metrics, if you will, to watch. Like maybe within your system, you decide that when I see 5 people signed in, or let's say 5,000 people signed into my website, I've created my own little ratio behind the scenes by measuring all these things. That 5,000 people signed in means I need to add 5 more servers to my infrastructure. You can create your own little system behind the scenes, but here's how it works. We start with our base of 5 servers, and let's say as the load grows, we can add more servers dynamically. This is not something where an administrator has to either physically get involved, like go to a data center and plug stuff in, nor even logically get involved. If you do this right, you can have Amazon Web Services start spinning up, we'll call them little drones or clones of your servers as the demand needs it. So what you see is, demand comes up, and you're doing this little outpacing system to where, even if suddenly you get a spike, you can say, okay, well, I see that spike coming. I'm going to scale my infrastructure massively to meet the demand. So the demand is like, wah, risking to get up there. But if you've done your metrics right and checked your calculations, you say, okay, well, I'm going to make sure that I always outpace those servers. Now, again, Amazon Web Services is a pay-as-you-go system. So, it's kind of like, bam, there's your Facebook posting. Everybody's like, woohoo, let's all sign up. And then, it's kind of like, okay, it drops off. And then, bam, nighttime, nightfall, and it comes down. It's 1 a.m. Well, Amazon cloud computing, I'm trying to think, Amazon Web, there's terms I haven't defined for you yet that I'm trying to, so we'll just say Amazon EC2 instances, right? I'm throwing it out there. We haven't talked about them, but Amazon EC2 instances can follow that load right along. They can say, okay, well, we'll scale down the number of actually, and we shut down our site, right? We went below the 5, curve it right there. Get back up to 5. So we can scale down our site to meet that, and so it's 1, 2 in the morning, and then 8 o'clock in the morning, somebody's like, oh man, I saw that post yesterday, I didn't have time, so you see that spike come back up. So Amazon Web Services, the EC2 instances, which are actually the machines that are running, can scale up as that demand grows. It's insane to even be talking about this kind of thing. And I know right now it's leading to a lot more questions like, how do you do that? Like, what do you mean bring up more machines? Don't you have to configure those machines? Don't you have to tell those machines that they're a web server? Don't you have to put the web pages on those servers so that they can serve that? Don't you? I mean, right now I'm feeling like in a don't you have to kind of abyss of questions. And let me tell you, there are answers for every single one of those questions. I know that's a cop-out right now. You're like, yeah, whatever. Seriously, there are answers for those questions that we will explore. That's what this series is here for. How do you do that? Before we look behind the curtain at the technical details of how you do that, I want to give you a big picture case study of somebody who did. Matter of fact, in the last nugget when we first defined cloud computing, I said Animoto was one of the case studies that I showed you on this page, and I actually clicked on that because I was like, who is that? I didn't know who it was. And they actually have a really cool site. What Animoto is, and I was like, wow, I can see why they're successful, is what you do is you upload pictures or videos from your iPhone, smartphone, Android, computer, whatever you want, into this, we'll call it a template system, and it creates YouTube-like movies out of it, with backgrounds and music and animation, to where it really helps you take all those, 1,500 pictures you have on your phone and make something cool out of it that you can send your friends without just dumping a whole bunch of pictures on them. So anyway, this site, when it got started, purely on Amazon Web Services. Now, throughout this series, we're going to look behind the curtain to see how that scaling is possible, but I thought I'd start it off with a case in point on Animoto. Animoto is I actually saw it when I was doing the last nugget. They were right here on the case studies, and when I paused the nugget, I clicked on it. I was like, what is Animoto? And I thought, what a great case study to follow. So what Animoto is a website that makes videos out of all of the picture and video junk that you and I have on our smartphones, computers, wherever else, right? Nowadays with digital photography, everybody takes 1,000 pictures of everything, but they quickly come disorganized and nothing meaningful ever comes of it. Well, what Animoto can do is you take, let's say, 15 pictures or whatever you want, or videos that you've taken and upload them to their system, and they've got this pre-configured templates that put them into a video with music and backgrounds and transitions. It just kind of makes YouTube-like videos on the fly, like renders them from the things that you upload on the fly for this. Now, just thinking about this kind of website, again, from an architecture sort of perspective, I think, okay, number one, you've got the main website page that's running. Behind the scenes, you've got some kind of engine where people are submitting pictures and videos to that needs storage, so you need some kind of storage capacity that's holding all of that. You need a rendering, and I'm talking a real rendering. This is my little gear, right? A real rendering engine, so that as people upload this stuff, it actually processes and spits out these videos in whatever format that is needed, web format. I don't know if they allow, maybe they let you download the video that you can burn to a DVD, or maybe, it's like iPhone, I'm sure there's a variety of formats that it has to generate that in on the fly, which takes processing power, CPU processing power, probably even GPUs, graphic processing power, to be able to render all these videos. So the case study looks something like this. Animoto was running along steadily at about, we'll say, 40 instances. When I say instance, that's a running server, like a running, nowadays we use virtual servers, right? Not just physical servers. So you might have one physical server running hundreds of virtual servers, depending on how much capacity it has. So they were running on 40 virtual servers, steady, just kind of up and down and up and down and up and down. Well, at some point in April of 2008, Animoto posted and integrated with Facebook, to where people with Facebook accounts could then, tie in with Animoto and put their videos and all that kind of stuff up there. And when they did that, it skyrocketed in a matter of 3 days. So I'm not talking like April 2008 to April 2012 or anything like that. I'm talking 3 days. They went from a demand requiring 40 instances up to, what's this cap? 5,000 instances. Seriously, 5,000 servers churning at the same time because of the massive response to this application on Facebook. Shot up there, and then after the initial buzz, I'm like, and then they plummeted. No, then I don't know. That's where the case study ends. I don't know what they are running currently, but the fact is, in a matter of 3 days, they moved from, I'll just call them servers, 40 servers up to 5,000 servers, and back down in that small time window. So traditional computing, if you were doing it on your own, would you be able to do that? Yes. I know you're like, huh? No. Yes. With a massive investment, with a guess of what you're going to be growing to. right? You hope that you have the demand to hit 5,000 servers, so you go buy a massive amount of servers to be able to handle that. And it's kind of like one of those field of dreams. If you build it, you hope they come kind of infrastructure. So you over provision up here, so you do meet the demand. But then when the demand tails off, now what are you left with? A whole bunch of servers that you have to either manually sell or power down or hope that you reach that peak again. And I don't know what Animoto is at on a normal basis, but if let me tell you, without elastic computing, without the infrastructure that Amazon Web Services provides, this wouldn't have been possible. Their Facebook would have been a massive disaster. Their company may have folded from it because it could have locked things up. People are never coming back. I can't believe it. Or they have to start investing in a massive way to handle this, which would require a whole bunch of upfront capital costs. I mean, from the business perspective, it's just like, oh my goodness. But imagine a utility-style computing system to where it's like electricity. You pay for what you use. You bring up a whole bunch of servers, and then you give them back. Where do you get that kind of thing, doing it yourself? I mean, how do you do that? You don't. You can't. You have to partner with somebody that is huge, somebody like Amazon Web Services. Well, let me springboard from Animoto into some key AWS terminology. You'll hear me refer to some AWS stuff that I talk about is like Lego building blocks, and regions and availability zones are probably the biggest building blocks I've got. What these are where your Amazon Web Services are running from. So in AWS lingo, a region represents a geographical area. For example, I live in Phoenix, Arizona. That might be a region, like Arizona might be a region, or Australia might be a region, or Europe, Western Europe, or you get that kind of thing. So as of right now, there are 9 AWS regions. Now, I'm talking to you as of today, and I will say this multiple times through the series. Things will change. They always do. Amazon Web Services is growing. Maybe by the time you hear this, there's 20,000 AWS regions. I don't know. But they will continue to grow. If you go to this website at the bottom, you can see where those regions are at. And I'll actually take you there right now. It's the global infrastructure. And you can see right here, it shows a map of the world. The yellow spots represent the official AWS regions. So for instance, I'm clicking on North America, which has the heaviest volume. You can see US East as in Northern Virginia, when it was launched, and how many availability zones that region has. Now I'm going to define that in just a second, but you can see here's Northern California, there's Oregon, and then there's the government cloud. So there's specific regions designed just for government services. So you and I can't put services in those regions, but it's there. It is an Amazon Web Services valid region. In each one of these regions, we'll have 2 or more availability zones. So what's that? Well, an availability zone is a data center. So for instance, we might have the US East region, which is Virginia, and you saw on that webpage, they have 5 availability zones. As a matter of fact, this was Amazon Web Services' first region. It's been around the longest, and it will always have, well, and I'll say to date, it has always had the most availability zones and the most services released first. So 5 availability zones means there are 5 individual data centers, distinctly separate locations in that region. So obviously Virginia is a big place, right? So you can have data center 1 located there, and then maybe 50 miles away is data center 2, maybe 10 miles from that is data center 3. There's 5 distinct data centers. Now you might say, well, so does that mean literally there's 5 data centers in Virginia that I can choose from to use? And the answer to that is absolutely yes. Now, when I think data center, my mind immediately goes to the data center that I use here in Phoenix, which is massive. I mean, just huge data center, thousands and thousands and thousands of square footage and so on. But I want you to change your paradigm into what a data center might look like. Can I show you a picture? That might be a data center. Matter of fact, that is a data center. Years ago, Google, I believe, was the one who forged this, started taking shipping containers that were used for overseas shipping. I mean, these giant containers that were essentially trashed by the time it was said and done, and turning them into a kind of build your own data center sort of factory to where they would install a whole bunch of servers in there, put all the essential elements that a data center needs, redundant power, security, all that kind of stuff, into this box, into this shipping container, and there it is. Now, this actually is from, it's one of the rare photos that you will see that came from an Amazon AWS presentation some time ago, where they gave kind of a sneak peek, if you will, of behind the scenes. You can Google around and find the full presentation, but this inside of here is just racks and racks and racks of equipment and servers. Now keep in mind, what you're seeing here is some of the magic exposed. As in, the fact that I even have this picture here is, I mean, I don't know if Amazon was like, I can't believe we gave that presentation, but I mean, just the fact that I can say, look, there's the data center is like, oh, some of the mystery revealed. All of this stuff is kind of magical. Amazon takes care of scaling the servers. They take care of implementing the switches and the routers and making sure they don't oversubscribe the network infrastructure. I mean, they do all of that. So it's meant to be kept as magical as possible. And for good reason. I mean, we want to be, clicking our next finish button in a web GUI and deploying amazing services without even thinking about it. And that's okay. So now let's get back to this page. Keep in mind, as a reminder, that not all regions have 5 availability zones. Not all, matter of fact, very few, if any, beyond Virginia do have 5 data centers inside of them, and not all services exist at all data centers. So let me click this see detailed list right here and take a look. Right here is a list of all the different regions that they have. Now, did I say not all services at each data center or region? I meant region. So Amazon Web Services deploys services as they see the demand for them in the individual regions. So you can see right here, Virginia, ooh, look at that. Every single one of Amazon services currently deployed there. Oregon, if you scroll down, you're like, oh, okay, we don't have AWS Cloud HSM. We don't have Simple Email Service. We don't so you start saying, okay, well, I want to make sure that I'm in Ireland. I'm in North Carolina, North California, and so on and so forth, based on what services you need and based on where your people are. I mean, if you are creating a website in Japan that services people in Japan, then Tokyo makes a great region to choose. Anywhere else, you're going to get the latency or the slowness from people connecting overseas or wherever the data center is located. So choose your region based on where your customers are at and the services that are required there. I want to show you what this looks like from the AWS Management Console. Now, I know I'm a little ahead of myself because you're like, what's the AWS Management Console? If you haven't signed up for an account, this is new. This is essentially your pilot's chair to configure all of the AWS services at your disposal. Now, I want to draw your attention to, first off, all the services. There they are. Upper right-hand corner, you notice it says Global. As in, things that you touch on this page affect everything around the world. It doesn't require a specific region selection. But watch this. I'm going to go into EC2, click on that, and immediately in the upper right corner, it chooses whatever region I was last in. So it says, okay, in North Carolina, matter of fact, Jeremy, you've got 0 running instances. There's no servers that are operational. There are 3 volumes that are running, 2 elastic IP address sets, static IP. I mean, it's like blah, blah, blah. We'll describe this when we get into EC2. But all of this is in North California. So it's kind of, you have essentially data centers at your fingertip. Check it out. I say, I want to go to North Virginia. And it says, actually, in North Virginia, you've got 2 volumes, 2 key pairs, 4 security groups, and all of these things as it relates to each one of those. And then notice underneath here, we have the availability zone status. So I've got all of these different AZs inside of Virginia. Now, wait a sec. I know some of you are very observant, and you're like, hold the phone, Jeremy. 3 availability zones? Are you saying that this hang on, let's back up. This page right here was wrong. You said 5 a moment ago. Notice the asterisk. It says new customers can access 3 availability zones in U.S. East, Northern Virginia, and 2 in Northern California. So it's like, even though there's 3 really there, new customers can only access 2 or 3 of them, depending on which area that you're looking at. Now, you say, well, what's that? My theory, my guess, if I were to say that, is they're probably phasing out 2 data centers in Virginia. They're probably phasing out 1 data center in North California, or maybe doing major upgrades to it, or that availability zone is maxed out, as in it's reached its capacity. They're not adding any new customers to that because it will exceed it. Whatever the case is, New customers can only access those specific availability zones. So now when you are going through, now you can see the availability zone status. I'm looking at Northern Virginia. When you set up an instance, or let's say I want a server in the cloud. This is how easy it is. You click on it and say, okay, well, send me through the classic wizard. You choose what kind of operating system you would want in there, and select that guy. And then it says, okay, which one do you want to launch into? This is where I want to hold, because I'm not going to go through all of this. This is for a future nugget. But notice it says you want to launch into no preference on the availability zone. Remember, since the availability zones are free communication, free high-speed connectivity, fiber optic connected between them, they're like, hey, throw it into one of them, or would you like to pick what availability zone you are in? Now, if I were advising you on design, which I absolutely will right now, I would suggest picking them. Otherwise, Amazon's just going to find whichever one has the most capacity and throw you in there. Well, if you're a designer, I would say, well, I want to make sure that I have some servers in 1A, and I'm going to put some redundant servers over here, maybe in 1B, so I know that they're in different data centers, and mirror them. So these essentially are a carbon copy of these and vice versa. That way, if an entire data center goes down at AWS, which it has happened, it's very rare, but it has happened because of natural disasters, because of stuff happens, right? So if an entire availability zone goes down, then I want to have a mirrored copy at a different one and a different one. So you can actually pick and design it to know which availability zones, essentially in human speak, which data centers your stuff is located in. Now also, let me come back to this global infrastructure page. I'm going to go to the detailed list. Some of these services are global. Matter of fact, 2 of them are. Amazon CloudFront and Route 53. So coming back to the management console, let's bail on this creation, go back to the services. You'll see that we have Route 53 right here, which is DNS, and then we have CloudFront, which is a global content delivery network, essentially making web pages available around the world for really fast response times when people are accessing them. Those are available from the edge locations. So when you're looking at this map, oh, wait a sec, back here. You see all the blue dots? The yellow dots are regions where you can put stuff that has availability zones. The blue dots represents edge locations where they're saying you can't put stuff there. We don't support hosting, private servers that you can manage there and things like that. But Amazon's like, we do have a presence there. We have stuff there. Maybe it's our data center. Maybe it's somebody else's that we have space in. It doesn't really matter to us. It is an edge location. That means if I deploy my DNS services, for example, I can say that I have a DNS server here, and I have a DNS server here, and here, and here, and here, and here. Just to give you an idea of how cool AWS is, you don't even have to use it for anything. You can just use it for DNS, right? Using Route 53 services. And, let's say you register your website through whoever, you can just say, I just want to use AWS for DNS purposes, which immediately gives you fast DNS response time around the world. That's a big deal. I don't know if you may have the biggest, baddest server in the world sitting right here in wherever, running your DNS. But if somebody over here accesses it, every single time they do a DNS lookup, they have to come across the. Have you ever seen at the bottom of the web browser that little bar that comes across, and it's like, resolving www.cbtnuggets.com, and you're sitting there waiting. Well, it wouldn't happen for CBT Nuggets, right? Because CBT Nuggets does use Amazon Web Services for everything, but if you were at, we'll say, a competitor, then it would sit here forever, trying to resolve and hopefully never resolve to the IP address, because it's trying to contact the DNS server in a far location. With AWS, you automatically get all of the worldwide DNS services, if you will, just by signing up, and it goes global. So that's what it's talking about when it's saying. Let me get back there. It's saying that some of the services are offered at the edge locations, but you don't pick that. It just happens. It goes worldwide. So this one I have to ask: how you doing? Give me your virtual response. Are you feeling it at this point? I know some of you are like blankly staring at the screen, going, "What do you mean feeling it?" I don't know what you're saying there, Jared. I mean, seriously, okay, elastic computing, right? The ability to go from one instance, one server in the cloud running to thousands of servers, and then back down to one in the matter of minutes as demand requires. I mean, if that doesn't get an IT person's blood flowing and go, okay, I can see some usefulness here. I mean, even looking at Animoto's case study, but I mean, that's one of hundreds. I mean, you saw that case study window where it's just scroll down of people who have done the same thing and proven that the model works. It's pretty amazing. So I think at this point you're starting to catch the vision of AWS. So last thing we talked about in here was regions and availability zone. Again, regions being geographical locations, availability zones being the data centers located in those geographical locations. Setting it up to have redundancy. There's high-speed connectivity between it, and I'll start getting. Unpacking this more. I think that's the best word I can use. Is right now we're still in the foundations, right? Like welcome to what this is. There is so much more that's possible as we start digging. Matter of fact, like availability zones, the thing that just popped into my mind. Amazon is now allowing you to connect into your availability zones from other data centers that aren't Amazon. So, for example, maybe you want to put a piece of equipment in that connects directly using fiber optic cable high speed to an availability zone. That's a possibility. So just keep in mind, if right now you have questions, you're like, can we do that? I mean, there's a lot more that's possible, and we will unfold that as the series continues on. For now, I hope this has been informative for you, and I'd like to thank you for viewing.